This video is on the exploratory challenge from lesson 24 in the grade 7 module 3 book found on page 148. So in this challenge we have a box in the shape of a right rectangular prism, has a length of 12 inches, a width of 6 inches, and a height of 8 inches. The base and the walls of the container are 1/4 of an inch thick and its top is open. What is the capacity of the right rectangular prism? Meaning, what is, or the capacity is equal to the volume of water needed to fill the prism to the top. So you'll start hearing that quite a bit. What is its capacity? That's just asking what is its volume? How much can you fit inside this object? So let's start this out with what we know about volume. We know that the volume can be found by taking the base shape's area and multiplying it by the height of the prism. So there's our rough draft. We'll keep filling this in. So let's talk about the base shape's area. In this case, the base shape, we got to be a little careful of, because even though they give us these measurements on the outside, remember, we are filling the inside of this shape, and the inside is actually has a little bit different dimensions. The walls are not paper thin. The walls are 1/4 of an inch thick. So our inside dimensions, we're going to have to adjust those. So our inside dimensions, we need to subtract 1/4 of an inch from 8 inches, because down here, remember, we're taking off this little 1/4 of an inch. So the actual height will be 7 3/4 of an inch. Down here, our base on this side, so if you look from here and here, that's another 1/4 of an inch. So instead of being 6 inches, we have to subtract 1/4 from 6 inches and then 1/4 again from the 6 inches, leaving us with 5 1/2 inches. And then 12 here and here are 1/4 of an inch thick. So we again have to subdue 12 minus 1/4 minus 1/4, leaving us with 11.5 inches. So how does this connect to our base shape's area? Well, the base shape will be a rectangle measuring 5 1/2 inches wide by 11 1/2 inches long. So we'll go ahead, we'll put that in. There we go, 5 1/2 by 11 1/2 multiplied by, now the height of the prism, remember we had that 1/4 inch thick bottom, so the height of the prism is 7 3/4 of an inch in actual space available in the inside. So we go ahead, we multiply those values together. 5 1/2 times 11 1/2 will give us 253/4 inches. I left it as a improper fraction for now. We're still going to have to multiply that by 7 3/4. I'm actually going to erase this inches. We'll tack that on at the end. After multiplying 253/4 by 7 3/4, we will get 7,843/16. Our final step, let's just write that as a mixed number, and we know how to use that. Do that using the calculator. We'll get 490 3/16 inches cubed, because this is volume. All right, so exploratory challenge, not too hard. Let's head down to example 1. So in example 1 it says a glass container is in the form of a right rectangular prism. The container is 10 centimeters long, 8 centimeters wide, and 30 centimeters high. The top of the container is open, and the base and the walls of the container are 3 millimeters or 0.3 centimeters thick. The water in the container is 6 centimeters from the top of the container. What is the volume of the water in the container? So we got a couple things going on here. That's similar to what we just did up there. So we have a container, it's filled with water, but the walls of it, these dimensions they give us, 30 centimeters, 8 centimeters, 10 centimeters, are the measurements from the outside. We have to remember that the water is taking up the space on the inside and that the walls are 0.3 centimeters thick. So the actual space available on the inside will be 8 centimeters. And remember, 8 centimeters is going from here to here. It's the length of this. The problem is there is a little space on both ends of this that are 0.3 centimeters. So here and there, this is 0.3 centimeters, and this little space represents the thickness of the wall. That's also 0.3 centimeters. So we have to do 8 to find out how much space is actually in between the walls. We have to do 8 minus 0.3, then minus 0.3 again. So you'll find out our walls are actually or the space in between the walls is actually 7.4 centimeters. The same is true for 10 centimeters. There's a little space here also that is 0.3 centimeters thick, and here also that's 0.3 centimeters thick. So we have to do 10 minus 0.3 minus 0.3 again, and we'll find out that our walls are actually 9, or our space in between these two walls are 9.4 centimeters thick. Now, up here with the 30 centimeters, 30 is the distance from the top to the bottom. And they just said the base has a thickness of 0.3. There is no top because they said that in the paragraph it's an open container. The top of the container is open. So we just have to think of this little space right here. So we're only subtracting 0.3 once because we just take it away from the bottom. So we'll have 29.7 centimeters right there. So these are the measurements we will think about first using to find our volume. But the actual volume is not the total volume in the prism, because we can see here they say that they want to know the volume of water in the container, and they filled the container so that there's 6 centimeters of space in between the top and the surface of the water. So we are going to have to factor that in. So to factor that in, our actual height from here to here, we're going to find out by doing 29.7, because that's the distance from where the water can fill to the top of the prism. So 29.7 minus 6 centimeters, which represents the empty space. So our actual height for the volume of that we're filling this with water will be 23.7. And now it's pretty simple and straightforward. Now we can just get into finding the volume of water in this. So to find the volume of water in this, again, we'll just do V equals, and it's going to be the area of the base. So area of the base will be 7.4 multiplied by 9.4. Again, those were the measurements for our length and our width of the base, multiplied by, now the height we have to use, since we're talking about the water, is 23.7 because that's the height of the space filled up by water. So the volume of the water in the container after we do all this multiplication will work out to be 1,648.572, and since it's it's a volume, it's going to be centimeters to the third power.